Hello and welcome. I am Mr. Murphy, and in this particular video we're going to be looking at Power Standard skill number 20. And in this particular skill we're going to multiply, divide, and simplify an algebraic expression dealing with rational exponents. Now that's what this Power Standard or this skill covers, but in this particular video we're just going to focus on multiplying and simplifying expressions dealing with rational exponents. In the next video we're going to look at dividing and simplifying expressions dealing with rational exponents. But since this whole skill is all about dealing with rational exponents, it'd probably be a good idea to understand what is a rational exponent. So let's start there. So we can see here that a rational exponent is where we have an exponent that is actually a fraction. Now, that fraction obviously has two parts. It has a numerator and a denominator. And remember, when we're dealing with exponents, the value, the item that's sitting on the ground, the item that's sitting on the floor, so to speak, that we call our base. And the item up in the air, that's what we call our exponent. So that exponent that's broken up into two pieces, a numerator and a denominator, those are very important. The numerator represents the exponent, or the power that we're going to be taking the number to. And the denominator represents the root. So for example, if I have x being raised to the 2/3 power, that would represent taking the third root of x and then squaring it. Because again, the denominator represents the root, and the numerator represents the exponent. Now, we're talking about, in this particular video, we're talking about multiplying expressions dealing with rational exponents. Well, it's also very important to know that when we're multiplying and the bases are the same, we need to add the exponents. And we get that from this postulate called the power of a product, or the product of a power postulate, which again states that if we are multiplying and the bases are the same, we add the exponents. Now, the question always arises, well, why is it that we add the exponents? Why aren't we multiplying the exponents? Well, the reason for that is this, and because that's a really good question. So let's look at this particular example to help illustrate why we add the exponents. Because let's say if we have x cubed times x squared. Well, remember what it means to cube something. It means to multiply it times itself 3 times. And x squared would mean that we would multiply it times itself 2 times. Well, x being multiplied times itself 3 times and then multiplied times itself 2 times, you see we have a total of 5 x's here. So our answer would be x to the 5th. And so that's what this postulate is trying to tell us, is that we could just simply add the exponents and get the same result. So we don't have to write it as a repeated multiplication problem. We can just use this postulate and know that we would add the exponents. But it's important to note that the bases have to be the same. So let's look at an example here where we have 4x to the 1/3 power times 2x to the 5/3 power. Now it's important to note that that exponent, the 1/3, only applies to the x. It does not apply to the 4. Now if this had been written where the 4x was in parentheses and the 1/3 exponent was outside the parentheses, then that would mean that it would apply to both the 4 and the x. But that is not the case here. But we're going to multiply these. So let's start by multiplying our numbers, the 4 times the 2. Let's start by multiplying those together and get 8. And now let's focus on the x's. Now remember, when we're multiplying and the bases are the same, which they are here, we add the exponents. And remember, when we're adding fractions, we have to have a common denominator, which we do here, in which case we only add together the numerators and the denominators stay the same. So if I have 1/3 plus another 5/3, I'd get a total of 6/3. Now it's important to note, if we ever have a fraction, whether it's an exponent or whether it's a base, we always want to simplify it. We want to see if it can be reduced. So 6/3 reduces to 2/1, or just 2, or you could say 6 divided by 3 is 2. So we'd have our answer is 8x squared. Remember, that square only applies to the x there, so that would be your answer. Well, what if, when we're dealing with adding together our exponents, what if we're dealing with fractions that have different denominators? Like, let's look at the next one. Here we have 3x to the 1/4 power times 2x to the 2/3 power. What would we do here? Well, we would still take the 3 times the 2, multiply those together to get 6. But now, and again, these bases are the same, so we can add together the exponents. So I'd have 1/4 plus 2/3. But again, I have the problem of having different denominators. So I want to change those denominators to be the same. I want to have a common denominator here. So I look to see what's the number that both 4 and 3 divide into. Well, they both divide into 12 evenly. So I'm going to change these. So this will be 6x. So I'm going to change these to have a denominator of 12. Now 1/4, if I took 4 times 3, that gives me 12. So I take 1 times 3, that gives me 3/12. So 3/12, sure enough, reduces to 1/4. I always check and make sure that's the case so you don't make a mistake there. And if I take 3 times 4 to get 12, I have to take 2 times 4 and I get, 2 times 4 and I get 8. So I'd have 8/12. And sure enough, 8/12 reduces to 2/3. So I haven't changed the value here, I've just changed the way it looks. And now I can add these together. I can add the exponents to get my final answer, which would be 6x. 3 plus 8 is 11, so I'd have 11/12 there. Okay, so I want you guys to try these two on your own. So why don't you pause the video and hit play to check to see if you answer these correctly. Okay, so let's see how you did here. You should have multiplied the 5 and 2 to get 10. And with the x's, since they have the same base, we can add the exponents. So 1/4 plus 5/4 gives us 6/4. So we're going to reduce that to be 3/2. Now, a note about that is it is okay, and we do want to leave these as improper fractions. If we have a numerator that's larger, you do not want to write this as 1 1/2. We can leave this as 3/2. For the next one, 7 times 2 is 14. Now the problem here is 3/2 and 5 and 2/5 have different denominators. So I'm going to change those to have a common denominator. So let's use 10. So I would have 15/10 plus 5 times 2 is 10, so we have to take 2 times 2 and get 4. So sure enough, 15/10 reduces to 3/2. 4/10 reduces to 2/5, so I haven't changed the value at all. I've just changed how they look. And now we can add those together. So we would have 14x, and 15 plus 4 would be 19, so this would be 19/10. That can't be reduced at all, so that would be your answer. Well, there you have it. That's skill, at least the first part of skill number 20, how we multiply and then simplify expressions dealing with rational exponents. So make sure you watch the next video so you know how to divide and when dealing with expressions with rational exponents. So with that, good luck.